Hello all, welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to multiply two matrix. Let me answer. First of all, the word matrix in this question means a two-dimensional array. How does a two-dimensional array look like? It will look something like this. Okay, I'll create two matrix, some example matrix. Before I multiply them, I'll create two matrix. Okay, just let's say 1, 2, okay, 3, then 4, 5, 6. I'm just giving some numbers 7, 8, and then 9. Okay, so this is one matrix. Okay, this is one matrix, guys. Okay, so assume that this is an example of one matrix. Then I'll create one more. This is one two-dimensional array. Okay, and the another one is another two-dimensional array. Okay, I'm going to create another two-dimensional array here. 9, 9, 5, 7, 6, 0, 8. Okay, 3, 5, 3, 5, 8. Okay, like this, I gave some random numbers, guys. Okay, so here, this another, okay, this is another matrix, which is nothing but a two-dimensional array. This is one two-dimensional array, this is another matrix, which is a two-dimensional array. If you have to multiply them, okay, if you have to multiply them, you have to be cautious here. How do we have to multiply? Assume that this is a first two-dimensional array, this is a second two-dimensional array. So in order to multiply them, okay, in order to multiply them, we have to do something here. Let me tell you. We have to multiply these columns. First element in the first column, that is here, second column, first element, third column, first element. Okay, 1, 2, 3. This one I have to multiply with 9. These two I have to multiply by 6. Here we are here looking for the columns. Here rows. First element in the rows. First element in the column should be multiplied with the first element in the rows like that. 3 will be third column, first element will be multiplied by this one. After this, what we have to do? For example, let's take the result. 1 into here. Have to, I'll just do the mathematics here. 1 multiplied by 9, how much? 1 9s are 9. So 9 plus 2 6 are 12. 12 plus 3 3s are 9. 9 2s are 18. 18 plus 12 will become 30. Right? 18 plus 12 will become what? 18 plus 2 is 20, right? 18 plus 2 is 20, and 20 plus 30 is 30. That's correct, 30. So here in the resultant, we'll get 30 as the first element. Okay, first year 30, 30 will be the first one. Then what happens next is, again this 1, 2, 3 will be multiplied by second column. Okay, 1 5 is a 5. 1 5 is a 5. You write down here. 1 5 is the first row. 1 5 is a 5. 2 zeros are 0, 2 zeros are 0, and here 3 5s are 15. 3 5s are 15. 5 plus 15 is 5 plus 15 is 20. So here the second element will be 20 here. Second element here in the resultant matrix will be 20. This is how we have to multiply the matrix. That is, this is how we have to multiply the two-dimensional arrays in Java. Okay. So now here 1 got multiplied with 5, 2 got multiplied with 0, 3 got multiplied with 5. Okay. Again the same 1, 2, 3 will be multiplied with the, these things. Last element in the row, last element in this row, last element in this row. Okay. The first elements in the columns will be multiplied with the last elements in the rows. 1 7 is 7. 1 7 is 7 plus 2 8 is 16 plus 3 8 is 2 8 is 16, 3 8 is 8 3 is 24, right? 24. So 7 plus 16 plus 24, 24 plus 16 will become 40. 40 plus 7 will become 47. So here the element will come as 47. 47 will be the resultant arrays, first row, last element. Okay. Now For the second one, we have to multiply 4 with 9, 5 with 6, 6 with 3. Okay. 4, 9 fours are 9 fours are 4 nines otherwise. 9 fours are 4 nines are 36 plus 5, 6 are 30, 5, 6 are 30. And here 6, 3 is 18. 6, 3 is 18. We have to multiply like this. It will become 66. 66 plus 10 will become 76. 76 plus 8 will become 76 plus 8 will become 84. So 84 will come here. Where? Here. 84 will come at this location. 84. The resultant two-dimensional array is getting created. Okay. So this is what is called as multiplying the arrays. Okay. Or matrix. Now, again, we have to multiply for the next element to come here. We have to multiply the second element in the first column. Okay. The second element in the first column with the second element in the first row. Okay. 4 5 is 20. 4 5 is how much? 20. 20 plus 20 plus 5. Okay. 5 0 the 4 5 is 20. 5 0 the 0 only. So 0 plus 6 5 is 30. 6 5 is 30. 30 plus 20 is 50. 50 will come here. Here result will come as 50. Okay. Now to get this last element here, again 4 5 6 should be second elements in this second element in the columns. Second element in the columns should be multiplied with the last row elements. Okay, last element in the rows. That means 4 sevens are 28. 4 sevens are 28 plus 5 8 are 8 5 is 40. 5 is 40. Then 6 8 is 8 6 is 48. 48. Okay. This will become 88. 88 plus 20 will become 98. 108. 108 plus 8 will become 116. 116. So the result will be 116. So here 116 will be added here. 116 will be the result. Okay. This kind of results we'll get, guys. 116. And then here now the third last element in the column, first matrix, that is two-dimensional. Okay. Last element in the first column of the first two-dimensional array will be multiplied with the, okay, will be multiplied with what? This will be multiplied with 963. 789 will be multiplied with 963. Okay. First element of the rows. Last element of the columns will be multiplied with the first element of the rows. So 7, 9, 7, 9, 6 are 9 sevens are. Okay. 9 sevens are. 7 sevens are 49. 7 8 is 56. 63. 9, how much, guys? 63, I guess. So, right? 7 10s are 70, 63. Okay, 63 is the result. 63, here we'll get 63. Then after 63, the multiplication is becoming very complex now. Okay, 8 6 are 48. 48 plus 9 3 is 27. 9 3 is 27. Okay, so we have to add them. 63 here plus 7 you add, it will become 70. 70 plus 20 will become 90. And if I remove this, it will become 90. 90 plus 40 will become 130. 90 plus 40 will become 130 and 8 will become 138. So 138 will come here. Okay, 138 will come here. Done. Then again 7, 8, 9 should be multiplied with the second elements in the rows. First row, second element. Second row, second element. Third row, second element, like that. Okay. Last elements of these columns, first column, second column, third column should be multiplied with the second element in this first row, second element in the second row, second element in the third row, like that. 7 5 is 35. 35 plus 7 5 is 35. Then 8 0 is 0 plus 9 5 is 45. 45 plus 35 will become how much? 45 plus 5 will become 50. 50 plus 30 will become 80. Here 80 will come. Here 80 will come. Okay. Here LT. Yeah, sorry. Here 80 will come. Okay. Here the result is 80. 80 will come. Then finally, last elements in this columns will be multiplied with the last elements in the rows. Okay, last element of the row, first row is 7, last element of the second row is 8, last element of the third row is 8. Okay, 7 7s are 49. 49, 8 8 is a 64, 8 8 is a 64, then 9 8 is a 72, 9 8 is a 72. Okay, like this. Now add it. Here plus 4 means 76, it will become 76, and here 60 it will become. So here 76 plus 60 will become 130, 136. Okay, the 60 will go off. Now here 9 will add and make this 145. Here 40 will be there, and 145 plus 40 will become 195. 195. So the result will be 195. 195 will be there here. Okay, in the last element 195. These are resultant array. Resultant array. After multiplying these two matrices, you'll get this kind of resultant matrix. Okay, which is a multiplication of first matrix and second matrix will result in this kind of stuff. This is how we have to multiply, guys. Okay, whenever you have to multiply the matrices, we have to multiply this is a technique. And there are a few rules also. Should have the same number of rows and columns. Whatever the matrices you are using and trying to multiply, right? They should have the same number of rows and same number of columns. For example, here 3 rows are there, 3 columns should be there. 3 rows are there, 3 columns should be there. And another rule is that, compulsory rule is that columns in the first matrix should have the same count as the rows in the second matrix. Okay. Otherwise, this multiplication will not happen, right? So here, if there are 3 columns, 1, 2, 3, here there should be 3 rows in the second matrix. These are the 2 rules. Then only we can multiply the matrix. So if you have the sizes of the matrices different, okay, the first matrix and second matrix are different sizes, and number of columns in the first matrix is not equal to number of rows in the second matrix, you cannot do this multiplication. You can still do that, but you have to, ignore something, and you have to write a lot of logic to get that done. Okay. But ultimately, it's whenever people ask you to multiply two matrix, they're expecting you to multiply the matrix of the same sizes. Okay. The rows and columns should be same, especially the columns in the first matrix should match with the number of rows in the second matrix. That is very important. Okay. That is very important. So once this is done, now let's write the practical demonstration how to get this in Java program. You see, for explaining only, it took me a lot of time, but how to make this practical, we have to work on it. I'll create a new class. I'll just name this class with some random name. Let's say class 27. Class 27. Click on main method, select the main method, and click on finish. And here I'll write down. I'll create two matrices, integer array, two-dimensional integer array, AR1 or AR1 you say, first array, first matrix, okay, mat1 also you can say, mat1, okay, or matrix 1, whatever you say. You can give any names, that's okay, array or matrix. This should be two-dimensional. I'll create the shortcut representation of this, okay, and it should have same number of rows and columns. So make sure that you are giving the same. I'll give the same example: 1, 2, 3, 4, 5, 6, 7, 8, 9, so that we can validate the result. Is it multiplying it properly or not? Okay, the same thing here: 1, 2, 3, 4, 5, 6, 7, 8, and I represented here. Okay, if I have to print this, particular matrix in this kind of display format in the output, for that I'll create a reusable method, guys, public static, because we have to call this method multiple times. We have to print two matrices and result matrix. So let's say print matrix. Once I say print matrix, I'll intake print matrix. The matrix, what is a matrix here? Integer array, right? Integer two-dimensional array. Okay, I'll say AR, whatever the array it may be, AR I'll say, and here I'll write down for each and every element. For each and every element in this two-dimensional array is an integer array. I'll just write integer array A colon AR. I'll write like the logic like this. This you see, each and every element of this two-dimensional array is a single dimensional array. It will be assigned for each and every single dimensional array. In the elements in the single dimensional array are individually they're int type. So int E colon A. Like this, I'll write the logic, and here I'll write down system dot out dot. Instead of println, I'll use print, so that all the array elements, single dimensional array elements, will be printed in the same line with some space I'll give. And after the inner for loop, I'll write system dot out dot println, system dot out dot println. That's it. Okay, to go to the new row. After 1, 2, 3 is there. In the new row, 4, 5, 6 should be printed. In the new row, 7, 8, 9 should be printed so that we'll get the output in this format. 1, 2, 3, 4, 5, 6, 7, 8. Okay, like this. Now, let's try and see whether if I pass this matrix to this print matrix, here I'll write a print statement saying first matrix, okay, that is first two-dimensional array. I want to print it. How to print it? I would call this method. And to this particular method, I have to pass the matrix elements that I want to print in the matrix format. Are two-dimensional array elements I want to print in the matrix format. So for that, I'm just passing this two-dimensional array name, object reference otherwise. Okay, run this code and see whether that is getting printed or not. First matrix, under that, we should get all the elements printed. 1, 2, 3, 4, 5, 6, 7. It's working fine. Now, I'll create one more matrix. To multiply this matrix 1 with matrix 2, I'll say mat2 is equal to, this is a two-dimensional array. Here I'll give the same values that I have given there in that explanation. That is 957, 608, 358. 957, 9, 5, 7, then 608, then 6, 0, 8, 6, 0, 8, then last one is 3, 5, 8, 3, 5, 8. 3, 5, 8, like this I'll write. So I'll call this method and just write down print matrix of mat2 into matrix of mat2 and see what will happen now. It will print the, here before printing, I'll just print it out, system.out.println, second matrix I am printing. Okay, you can call this method any number of time, print matrix method. Whenever you have the matrix to be printed, you can print it. Now we also have to multiply this two matrix and then get the resultant multiplied matrix. Okay, after multiplication, whatever the resultant matrix will come, which is nothing but equal to like this 30, 20, 47, 84, 50, 116, 138, 80, 195 should come for us with this example. So for that to happen, we have to create a method, guys, and to calculate that, to calculate that multiplication of these two matrices, I'm going to create a method, another method, public static, so that the logic can be separated. Multiply matrix. Matrix or matrices, whatever you say, matrix, I'll say multiply matrix. Here I need to pass two matrix 1 and matrix 2. I'll say AR1 int integer array, two-dimensional integer array AR2. I'll give the names like this, AR1, AR2 here. Okay, fine. Then this matrix, when I have to call this method, I have to call like this, multiply matrix. I have to multiply the matrix and I have to pass the two matrices, matrix 1, comma, matrix 2. Matrix 1, comma, matrix 2 I have to pass. Matrix 1, comma, matrix 2 I have to pass. Once I pass that, what will happen? We'll call this method and we have to do the logic here. First, we have to find how many rows are there. Here, already we have known that the number of rows and columns should be equal. So whether you go to this matrix or this matrix, they should have the same number of rows and columns. And the number of columns in this first matrix should match with the number of rows here. So rows will be same, most probably the rows will be same in both the cases. Okay, if there are 3 rows, here also 3 rows will be there. Okay, int rows is equal to any of this matrix you take, for example, matrix 1 or matrix 2. Simply say mat1 dot, sorry, here mat is being passed to whom? AR1. So I have to say AR1 dot length. It will get the number of rows. How to get the columns? Int columns is equal to, here both have the same number of columns here. Here 1, 2, 3 is 3 columns are there, 9, 5, 7, 3 columns are there. So how to get that columns? Either matrix 1 or matrix 2 you can take. I'll take any of the things, like let's say matrix 1 only I'll take, and AR1 of first row. First row will have the first single dimensional array. Will have how many columns are there? It depends on how many elements are there in the first single dimensional array. Length. Array of 0 dot length will give you number of columns. Okay, that's fine. Now we got the columns and rows. Now I have to write the logic like this. Three nested for loops you have to use. External for loop will be 1. Inside the two inner for loops will be, total nesting will be 3 layers of for loops will be there. Int I is equal to 0, I less than, rows I will say I plus plus. Okay, why we have to go with the rows here? Let's understand the logic here. I is equal to 0. Okay, let's go to the diagram here, understand. Okay, I is equal to 0. Int I is equal to 0, I less than rows, I plus plus. Okay, so rows, I'm counting the, I'll go with the rows first. Okay, I'll iterate through the rows. 1, 2, 3. Okay, row 0, row 1, row 2. Okay, I'll take that. First, I have to take the first row. That is 1, 2, 3 have to take. First, in the first matrix have to take the first row that will have the 0th index. Okay, the index of that row will be, the first matrix will be 0. Okay, and yeah, we'll write like that. Okay, that's the reason we are iterating from I is equal to 0 to I less than rows I plus plus. Here I'll say int j is equal to 0, j less than columns. I'll say columns, j less than columns, j plus plus. Okay, I'll explain the logic because there are 3 for loops, right? It will be difficult, so I'll explain the logic. Int k is equal to 0, k less than columns, k plus plus. Just understand here what's going to happen. Now I'll create a resultant matrix first of all. Okay, before making you guys understand this, why these 3 loops we have to write, inner for loops we have to write here. We'll create a resultant matrix that should be of 2-dimensional array only matrix. Okay, I'll say res. Resultant matrix is res, name I'm giving. Okay, then name of the resultant matrix is res, and here I'll create new rows and columns I have to give. Okay, number of rows is equal to rows, number of columns is equal to columns. This columns I'll give. Okay, like this I'll create a resultant matrix already created. Now simply res of I j. This is what you have to write. Res of I j means what? This area, this one, this 30 is there at that position we are talking about. Res of ij. Here I is what? When for loop is running, initially I is equal to 0, 0 less than number of rows is equal to 3, 0 less than 3 is true, will go inside the main for loop. So inner for loop will come, second level for loop will come. Then j is equal to 0, here j became 0, j also became 0, 0 less than columns are equal to 3 only. Columns also 3 only, then only this will be done. Otherwise you cannot multiply the matrices. So columns is equal to 3. So 0 less than 3 again true, will go inside that. Another for loop will come where k also will become 0. Where k also will become 0. 0 less than 3 again true, will go inside that. Here ij means what? 0, 0. I is 0, j is 0. So here I is 0, j is 0. Let's assume that I is a row and j is a column. Okay. So row is 0, column is 0. That means 30, whatever the value 30 is there, right? That one. There we have to get 30 as a value. Is equal to, we have to write like this. Is equal to, initially, there's nothing assigned. I'll simply write plus. You have to see what to do. Here, there's something, guys, you have to understand why we are writing like this logic. I'll tell you. Here, in order to get this 30, I have to multiply this 1 with 9, 2 with 6, 3 with 3. How that will happen? How can I multiply that? 1 with 9, 2 with 6, 3 with 3. The first columns here, row is 0. Okay, here row is 0. The first one, the first matrix, row is 0, and column is how much? Column is 0, 1, 2. 0th column, first column, second column. Okay, here row is not changing, column is changing. To get these elements, row is not changing, column is changing. So to do that, I have to write here. AR of 1 of, in the array 1 of 2 square brackets you give. This is first array, right? The first array, that is nothing but this array. In that, it should be I. Here it should be I because row is not changing. So it should be I. I is 0, right? I will be there. Then here, column. Okay. So here, actually this row is not changing. So I is 0, but columns are changing. Here 0th column, first column, second column. This 1, 2, 3 I have to get means 0th column, second column, third column. How to get the 0th column? Here k is changing, right? Here j is not changing. So here we have to take the help of the k. So k will become 0 inner for loop, right? So this will iterate, not the j is equal to 0 will not iterate. So here we have to give k. So what happens in this case? So in the first iteration, I will be 0, the row will be 0, k will become 0. 0, 0 means this 1 will be taken into consideration. Okay, 1 will be taken into consideration. That need to be multiplied by AR of 2, we have to carefully give this, guys, okay? If you understand this, how they are getting multiplied, then only you will be able to write the logic here. AR of 2. AR of 2 is this one. In this 963, I have to get. Here, column is not changing, rows are changing. Column is not changing, rows are changing. So, since the rows are changing, here, whatever the number that will change here in this inner for loop, what is the thing? K will change. So, better to write K here. Okay? For the rows. Rows will change, but columns will not change. Columns will be 0 only. Columns will be 0 only. So I you have to give it. This is the way you have to write the logic, guys. Otherwise, you'll not understand. So based on how you are multiplying, you have to give this. This is very, just watch this video 1 or 2 times if you are not able to understand what I'm trying to do here. So this one, why I'm saying again result of ij is equal to result of ij plus again multiplication, why I'm saying, why? Because here you see 1 will be multiplied by 9. Okay. After multiplying that, so to that result of ij will add that, and result of ij will have 1 9s and 9 will come. Okay. Then it will take in the next iteration, k will become 1. When k will become 1, okay, ik 0k. 0k means 2. 2 into k is 1, 1 0. What is 1 0? 1 0 is this one, 6. 2 6 are 12. 9 plus 2, 12, 12. Okay. Earlier result was 9, 9 plus again 9 plus 12 will become. That will be the result. Now finally k will become 2, 0, 1, 2, right? 2 less than 3 is 2. And here 0, 2, 0, 2 is this 3. And 2, 0 is nothing but this 3. 3, 3 is a 9 plus 9. Okay. 9 plus 12 plus 9, 30 will be the result. That's it. 30 is the result. That's it, guys. Okay. This is what we have to do. And we have to print that results and all. Okay. So anyhow, we are adding the elements to the array list. So ij will complete and will come out of this inner for loop. Then j will happen. So let's iterate this and see what is happening, whether we are getting the result as is this, the logic is working or not. Hope you understood how did I write the logic here. Okay. So here first initially I is equal to 0, guys. 0 less than 3 is true. 0 less than 3 is true. Okay. So we'll go inside the for loop. Then j is equal to 0, j becomes 0, 0 less than 3, again true, will come inside, columns are also 3, so 0 less than 3 is also true, and int k is equal to 0, k also becomes 0, 0 less than columns is 3, so again 0 less than will come inside. Result of ij is what? This result is this one, okay, result is this one, result of ij means I is 0, j is equal to 0, I 0 0 means this area, what should be the result? This is 0, this is 0, okay, is equal to result of ij. At this moment, initially, result of ij will be 0 only. Okay. By default, if you don't assign anything, it will be 0 only. 0 plus, what is k here? K is 0. So I is 0, k is 0. I is 0, k is 0. AR of 1 of 0, 0. That means this one. AR 1 of 0, 0 means this one. I and k means k is also 0 here. K is also 0 here. I is also 0 here. 0, 0 is 1 and, sorry, 1. That's it, 1 minute. Okay. This is one, nothing but 1. Okay, 0, 0. Then AR of 2 of ki. Currently k is 0, I is also 0. In the second array, the first element, that is 9. They both need to be multiplied. 1 into 9 is equal to, the result is what? 9. So 0 plus 9, the result will be stored as 9. Here, result of ij will have the current value of 9. Now k plus plus will happen, k will become 1, guys. Then 1 less than columns, 1 less than 3 is true. We'll go inside that. Now, again the same result ij have not changed, guys. Current value of result of ij is 9, right? 9 plus AR of, this is 9 plus, what is the result? AR of, now k has become 1, 0, 1, I is 0 and k is 1. 0, 1 is what? 0 row, 1 column. So it will take 2 here. This time it will take 2 here. 2. So this is nothing but 2. 2 into AR of 2. In the second array, ki means 1 0. 1 and 0. 1 0. First row, second row. Index 1 means second row. And I is 0. Column is 0. Okay. That means 6. It will take 6, guys. This 6. 2 will be multiplied by 6. 2 6 are 12. So here result will be 9 plus 12. 9 plus 12 is how much, guys? 9 plus 12 is 21. So 21 will be assigned to this result. Current value of result of ij is 20. Now k will become k plus plus, that is k will become 2. 2 less than 3 is true. We'll go inside that. Result of ij. Ij have not changed. The same 21. So 21 plus 21 plus here air of ik. Ik means I is 0 here still. K has become 2. 0, 2 means what? In the first array, air of 1 means first array. 0, 2 means 0th row and second index column. 0, 1, 2. That means 3. Here 3 will come. Here 3 will come. Okay. 3 into 3 multiplied by second array. Second array, AR2 means second array. In that KI. KI means 2, 0. 2, 0. 2 is what? 2 is a row number. 0, 1, 2. That is third row. In that column is 0. In that column is 0. In that column is 0 means the first element. Okay. First element in the last row. Third row. Okay. 3. 3, 3 is a 9. 3, 3 is a 9. Okay. Here 3 came. Here 3 came. 3, 3 is a 9. Okay. 9 plus 21, how much? 30. So resultant will be 30. In the 0, 0, 0 index, 30 will come here. Like that it will work, guys. Now what happens after that? K plus plus will become 3. 3 less than 3 will become false, will come out of this for loop. We'll go to the next layer of for loop where j will become 1. Here j will become 1, guys. 1 less than 3 is 1 less than 3 is 2. Will come inside. Again k will become 0. Now result of ij. I is 0 only. J is 1. Okay. J is 1. That means what? In the resultant array, row is 0, column is 1. That means this part 0, 1 means this 0, 1, column 0, column 1. That means here 20 result will come. We are actually calculating the 20th result now. So 20, how that 20 will come? Because here initially it is 0, guys. 0 plus initially that element is 0 in the resultant array. 0 plus AR1 in the first array, IK. IK means I is 0. K is also 0. 0, 0. That means 1. That is nothing but this particular 1. 1 into. So 1 multiplied by, what is this? AR2 of Ki. K is currently 0 only. I is also 0 only. Okay. In the second array, 0, 0. In the first element only. Right? 1, 2, 3. 1 minute. Let me see. So here what should happen? 1 should be multiplied with okay, 5 actually. 1 should be multiplied with 5. That means what should happen here? Can I say Ki here? Yeah, K is 0 and I is also 0. Assume that I is also 0. Then what is happening? Let's say. So K, I think J should be considered, guys. Okay. Here K should be 0 means K is 0 means in the first row, first column should be, second column should be taken. For that, this should not be I, guys. This should be J here. Okay. That's the, you see, this is how we have to decide the logic, guys. Okay. Looks complex, but this is only way IK, KJ. Okay. Then only we'll get the result. Okay. So IK is okay. KJ will become what? KJ will become, this 5 will come. Okay. Because of that, it will come as 5 because K is 0 now. J is 1. 0, 1 means 0, 1. This one. Fifth. Okay. Index 1 means second column. That will become what? 1 into 5. 1, 5 is a 5. It will become 5. 5 plus 0 is 5. 5 will be stored into the 5 will be stored into this result of ij. Okay. Now again 5 plus the next iteration k will become 1. 1 less than 3. Here ik. What is ik? I is still 0. K is 1. 0 and 1. That is 2. 2 into here 2 plus 2 into, okay, 2 into kj. Kj is nothing but k is 1, j is 1. 1, 1. So here 1. Second row is index 1 and column 2 means index 1 again 0. 1 into 2 into 0. 2 into 0 is 0 only. That means the result will be 5. Again 5 will be there in this result. Again 5 plus in the third iteration when k will become 2. 2 less than columns. 2 less than columns. 2 less than column means 3. That is true. We'll go inside that. Result of ij is nothing but 5. 5 plus array 1 ik. What is I? I is 0. K is 2. K is 2 means this 3. 3 into 3 multiplied by kj. Kj means what? K is 2 and J is 1. 2, 1. What is 2, 1? 0, 1, 2. In that 1 is 5. So 5 will come. Okay. Here 5 will come. 5 3 is a 15. 15 plus 5 will become how much? 20. So 20 will be stored into. Okay. By iterating this, you see, I corrected the logic, guys. Otherwise, I'll not get the logic. I thought here I should be kept, but here J should be kept, guys. Result of Ij is equal to result of Ij plus Ik kg. Okay, like that you have to write. Now 20 will go here. 20 will go into the this resultant part. 20 came here. Okay. Now what happens here? It will become 3. 3 less than 3 will become false. Will come out of the inner for loop. Here will come J will become 2. Okay, 2 less than 3 is 2 will come inside that, and K will become again, K will become 0. K will become 0. J is 2. Okay, result of Ij is 0, 2. What is 0, 2? 0 and 2. 47. This 47 element is 0, 2. And here we'll explore few more. Okay, and after that we'll start. Okay, 0, 2. 0, 2 will come to the 47, and in that 47, 0, 2 actually will come to the 47, and okay, 0, 2 will come to 47. The result should come. Okay, initially it is 0 actually. Initially, that particular position is 0. 0 plus array 1 of ik. Ik means I is 0, k is 0. I 0, 0. That is 1 only. Okay, 1. 1 into 1 multiplied by 1 multiplied by kj. Kj means k is 0, j is 2. The second array 0, 2. 0, 0, 1, 2, 7. 7. So 1 into 7. 1 into 7, right? That is nothing but 1 multiplied by 7. So the result will be 7 here. 7 will be stored into this result of Ij. And now K will become 1. The things will repeat, guys. This is what will happen. 1 less than or equal to 3 will be true. Again, we will come inside that result of Ij. That is 7 plus here of Ik. Ik is, I is 0, K is 1. 0, 1. 0, 1 is nothing but this 2. So 2 into 2 multiplied by kj. Kj is nothing but what is k? K is 1, j is 2. Okay, 1, 2. 1, 2. 1, 2 is what? In the second array, 1, 2 is 0, 1. In that 2. 0, 1, 2, 8. That is 8 to the 16. 2, 8 to the 16. 16 plus 7, how much? 16 plus 7, how much? 23. Right? 23 will be the result. 23 will be stored into the result. So in the next iteration, will become k will become 2. 2 less than 3 is 2. Here 23 plus AR of 1 ik. Ik is nothing but what? 0, 2. What is 0, 2? This 3. 3 into 3 multiplied by kj. Kj is nothing but 2, 2. 0, 1, 2, 0, 1, 2, 8. So here 8 into 3 into 8. 3 into 8 is 24. 23 plus 24 will become 47. So 47 will be stored here. And this will become 3. 3 less than 3 is false, will come out, and j will finally become 3. And 3 less than 3 again will become false, will go back, and here I will become I plus plus, I will become 1. 1 less than 3 is true, again will come to the inner for loop. Okay, like this, guys. Here 47 already came, and now I became 1, j became again 0. 0 less than 3 is true, again come inside. Here k became 0, k became 0. 0 less than 3 is true again. So result of Ij will be 0 here. Initially it will be 0 plus, because Ij means 1, 0. 1, 0 is initially true. Initially 0. 0 plus in the first array Ik. What is Ik? I is 1, K is 0. 1, 0. 1, 0. Fourth element. This 4. 4 will be multiplied by AR of 2 Kj. K means 0. J is also 0. 0, 0. That means 9. 4 9s are 9 4 the 36. So 36. 36 will be stored into this. Then K will become 1. Okay, like this it will keep on going, guys, and this row will be multiplied with the first column. This will be multiplied with the first column elements, and this will be multiplied with the second column elements. You will get this one. This will be multiplied with the third column elements. This will be done. And again, in the next row, this will be multiplied with this one. This will be multiplied by this one to get this one. This will be multiplied by this one to get this one. So you should get the result. So hope I don't have to iterate all the iterations now, but we were able to crack the logic, okay, by experimenting there. Okay, I'll remove all this stuff which are not required. Okay, let's run this, and you see, whatever the elements that are stored into the result array, I would like to return that. Whoever is calling this, have to return that. So I'll return the resultant matrix, that is resultant two-dimensional array I will return. The return type should be integer, two-dimensional integer array here. That will be gone. Then once you call this multiply matrix, multiply matrix is returning you a return type int res mat, resultant matrix. Resultant matrix we are storing. I would like to print it out. We have already have a print matrix method. I'll call this method to print the resultant matrix. Whether we got a proper result or not, we have to see. For that result matrix, I'll pass this so that that will be printed. Before printing that, I'll write a print statement saying resultant matrix, result matrix after multiplication. After multiplication, you have to write and run the code. Right click, run as Java application and see what will happen. You see, did we get the output as we thought? 30, 20, 47. Yes, 30, 20, 47. In the second row, 84, 50, 116. 84, 50, 116. Third row, 138, 80, 195. 138, 80, 185. Okay, here 195 I gave. So where is the mistake? Let's see. 789, 788. 7 7s are 49. 49 plus, there's some mistake there. Let's see what is correct, what is wrong. So in the last one, 7 7s are 49. Let me add it here. It's taking some time here. 7 7s are 49. 49 plus, what is the next one? 7 7s are 49. Then 8 8 is 64 plus 64 plus 8 8 is 64. 9 8 is 72, right? What is the result? 185, guys. I wrongly calculated there. The mistake is not in the here. Here it should be 185 only. Here 185. It should be 185, guys. So we got the result properly. We got 185. That's correct only. Okay. I calculated it wrong manually. Okay. So this is how we can multiply the two matrices in Java. Okay. This is a logic we have to remember. Okay. This is a main core area of this program. If you have to get the result, you have to understand this logic. Then you will understand everything. So fine. So these are, we already got result, guys. So now we can take a screenshot of this main method. Hope you have taken the screenshot of the main method. Now take the screenshot of this multiply matrix method where we have the logic for this, how to multiply. Once you have taken the screenshot, hope you have taken the screenshot now. And third one, how to print the matrix, you can take the screenshot. After you've taken the screenshot, write yourself in the editor and try to get the same result and try to understand the logic multiple times here in this area. If not understood, go back to the rewatch this video multiple times until you get this and try to understand. Okay. So hope, guys, with practical demonstration, I've answered this question for you. That is how to write a Java program to multiply two matrix. That is to multiply two-dimensional arrays. For that, the two-dimensional arrays should have the same number of rows and columns, and the columns in the first matrix, that is first two-dimensional array, should match with the number of columns in the first two-dimensional array should match with the number of rows in the second two-dimensional array. Then only this multiplication will be possible. Otherwise, things will become more complex. Okay. So this is what, guys, hope you got the answer for this question. It's if you practice this kind of stuff, right, your confidence on Java will increase. So hope, guys, you got the confidence levels increased, and hope you will be ready for answering this kind of questions when you come across such kind of questions in the interviews. So that's all for this session. Thank you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer one of the Java interview questions. That is, write a Java program to get the transpose of a matrix. Let me answer. First of all, what exactly is a matrix? Matrix is nothing but a two-dimensional array in Java. And what do you mean by transpose of a matrix? I'll explain you that with an example. Let's say there is a two-dimensional array. I'll just write down a two-dimensional array like this: 1, 2, 3, 4, 5, 6. Like this, let's say we have a two-dimensional array like this. Okay. having this number of elements. Okay, 1, 2, 3, 4, 5, 6. Now, here, this particular element is available at the row 0 and column 0. This one at the row 0 and column 1. This one at the row 0 and column 2. Coming to this one, row 1, column 0. Row 1, I mean, it's like row 0 means index 0, guys. Row 1 means index, index 1. Okay, so that's second row, but index is 1. Okay, so here, this one is row 1, column 1. Row index 1, column index 2, like that. So now, in such kind of situation, if I have to create a transpose, this one, that is a transpose of this particular matrix, then it will be created like this. If I have to apply the transpose for this particular matrix, it will be like this. 0, 1, index 0, row index is 0, and column index is 0, sorry, 0, 0. So here, if you reverse that 0, 0, okay, the column as row and row as column, still it is 0, 0, so 1 will be in that position. Then if you take the next element, that is, this is 0th row index and column is 1, 0, 1. So that will go to 1, 0. 1, 0 means here, okay, column 0 and row 1 index. Okay, index 0, column index is 0 and row index is 1. So here 2 will come here, 2 will come here. Then if you go to this 3, it will become 0, 2. So you have to reverse it. Instead of 0, 2, you have to make it as 2, 0. 2, 0 means what? 2, 0 means 2 is the index of the row that is here, and 0 means column index now. Okay, whatever that was there, 0 was the row index here, that has become the column index, and whatever the column index was there, that is 2, has become the row index here. Okay, now coming to 4, this is 1, 0, that will become 0, 1, 0th row, and column index is here. It will 4 will come here. Then 5 is 1, 1. That will be here. 1, 1 also is same here. 1, 1, index 1, 1. Okay, 1, 0, 1. So here 1, and in that 0, 1, here 1. Okay, 5. 5 will come, and here 6. 6 is at 1, 2, 1, 2, right? 1, 2. It will become 2, 1. 0, 1, 2, 2, and 1 means 0, 1. That is 6. 6 will come here. So this is what is the transpose matrix of this original matrix. Okay, this is a resultant matrix, which is a transpose of the earlier matrix. So whenever you get a question in the interview asking you to write a Java program to get the transpose of the matrix, you have to convert this kind of two-dimensional array to this kind of two-dimensional array where the rows and columns will swap. Okay, row and columns will swap. So let me write a Java program for that. Let me go to the appropriate place. I have a workspace for this. Let me go to the workspace. Just give me a second. So now in this Eclipse IDE, under this package, I'm going to create a new class. I'll just name this class with the name, some random name, let's say class 28. Okay. Click on this main method, select the main method. Here class with the main method will be created. And here I'm going to write the code. That is, I'm going to create a two-dimensional array, integer array. This is a matrix, right? Mat1. I'll say matrix 1. And here I'll try to create a two-dimensional array like this. Like this, I can create a two-dimensional array, whatever I want. And here I'll say 1, 2, 3. Let's say 4, 5, 6. I think this is enough. Okay, the same example I'm taking 1, 2, 3, 4, 5, 6. So I created that two-dimensional array here already. I would like to print this array. Okay, I would like to print this array in the form of matrix. I'll create a method for that. Public static void. Okay, print array. Print matrix. Okay, print matrix, and I'll pass the integer array here. I'll say AR. Whatever the array you pass it here, two-dimensional array, that will be printed in this kind of format. Okay, that's what is the requirement. Okay, so I'll first create the program for that. So first of all, whatever the array comes, for int I is equal to 0, I less than AR dot length. Okay, AR dot length, then I plus plus, then I plus plus, like this I'll write, and inside the for loop I'll create one more for loop writing for int j is equal to 0, j less than number of columns, that is AR of one of the row dot length. Okay, it will get the number of elements here. Here 2 are the number of rows and 3 are the number of columns. Columns will come here. Then semicolon j plus plus. Okay. So what is the problem here? Try to write the for loop body, then the error is gone. So this is the logic I'm writing, guys. Okay, to print that particular array in that format. Okay, I'll just reduce the number of lines here. Okay, here I'll write down system.out.println. Instead of println, I'll use normal print statement. I'll write down AR of, okay, I'll write down AR of I, J. Okay, so array of IJ. Okay, array of IJ. So whatever the array I got, that array index I, row J and column, row I and column J. Okay, and after that I'll put some space here. Okay, this so that in the same row the numbers can be separated by space. And here I didn't use println because I want to print all the elements in the single line, and in the next line I'll write system.out.println. I'll write down AR. I'll print the array. That's it. Sorry, you should not be writing here. We have to go to the new line basically. Before going to the loop, we have to, here it is anyhow printing the array, right? We just go to the new line before going to the external for loop. Now, is there any problem or question problem here? Let's see, save this and just open this one. Some temporary glitches will happen sometimes. Yeah, here H is there. So let me save this. Okay, now run the code by calling this method print matrix. And this is not the exact logic for whatever the question we got. This is only for printing the matrix, printing the two-dimensional array in matrix format. So I created a reusable method which will intake the array and print the array elements in matrix format. So for that, we have to write this kind of code. I'll explain this code if you want, how it is printing and all. Run this code and observe that in the output, we'll get, you see, the original matrix. Okay. So here I'll write, before printing, here I'll write system.out.println original matrix. Okay, original matrix looks like this. Okay, 1, 2, 3, 4, 5, 6. Run this code again. This time, original matrix label also will be printed. Under that, the original matrix will be printed. Now, what I want to do next is, after this, what I want to do next is, I want to transpose. Okay, I want to transpose this matrix. Okay, that I want to do. For now, how this code is working, I'll tell you. Here we created a two-dimensional array and we passed the two-dimensional array. This mat1 has come here into the AR. And here int I is equal to 0. I has become what? 0. Okay. 0 less than AR dot length. How many rows are there? Row 1, row 2. Right? 2 rows. So 0 less than 2. 0 less than 2 will be okay. Then we'll go inside since the condition is true, we'll go inside this for loop. Inner for loop will come. Int j is equal to 0. Here j is also 0. J is also 0. 0 less than AR of 0 means this AR of 0 is this one. In that, what is the length of this 1, 2, 3? 0 less than 3. Okay, that's also done. This is also true. We'll go inside that. Here we are going to print. It's not println, it's print in the same line. AR of IJ. I is 0, J is 0. 0, 0 means it will take this one. This is 0. In that 0, again 0. That is 1. So 1 will be printed here. Here 1 will be printed, guys. Okay, 1 will be printed. Here 1 will be printed. After the 1 gets printed, J will become 1 here. 1 less than 3 is again true. We'll go inside that. Here, AR of 0, 1. What is AR of 0, 1? AR of 0 is this one. In that 0 and 1 means 2. Here, already space is there. After 1 space, 2 space will be printed. 2 and space will be printed. then j will become 2. 2 less than j plus plus means j will become 2. 2 less than 3 means it is true again. We'll go inside that. Here air of 0, 2. 0, 2 means what? 0 is this one. In that 0, 1, 2. That value 3. 3 and space will be printed. That's it. Okay. Now, after this, what will happen? J plus plus will happen. J will become 3. 3 less than 3 is false. Will come out of the inner for loop. And here there is a print statement. Because of the print statement, this is what will happen. It will go to the new line. The output will go to the new line like this. Okay. Now, because of the print ln, we will go to the new line. And here I plus plus will happen. I will become 1 here. 1 less than 2 is true. We'll go into the inner for loop where j will become 0. Again, 0 less than 3. That is again true. We'll go inside that. AR of ij. I is 1. J is 0. 1, 0 means what? This is 0. Air of 0 is this one. Air of 1 is this one. Air of 1 we have taken. In that 0 means 4. 4 will be printed here. Okay, with a space. Then after that, j plus plus j will become 1. J will become 1. 1 less than 2 is 3 is again true. We'll go inside that. Okay, air of 1, 1. This is 0. This is 1. In that 1, again 1. 0, 1. 5 will be printed here. Okay, with a space. After that, j will become 2. 2 less than 3 is true again. We'll go inside that. Air of 1, 2. What is 1, 0, 1? In that 1, 2. 0, 1, 2 is 6. 6 will come here. Index 2 is 6. Okay. After that, j will become 3. J plus plus j will become 3. 3 less than 3 is false. Will come out of this for loop. And here I will become 2. 2 less than 2 is also false. 2 less than 2 is also false. Will come out of the external for loop. Okay. That's it, guys. We are done. Okay. That's it, guys. We are done. Okay. So here 1, 2, 3, 4, 5, 6 will be printed. That's the reason the array will be printed in the matrix format. This is the logic we have to write. I'll remove all this stuff. This just for explanation I have written here. Hope you got the idea how they will be printed. Okay. Fine. That's all good. Now the next thing here is save this. The next thing here is int mat of 1, 2, 3, 4, 5, 6 original matrix. We have printed that how it is getting printed, but I would like to get the transpose of this matrix. I would like to transpose this matrix. For that, I need to change the row number into the column into the row. I have to swap the rows and columns. I explained already, right? If I change the row index to the column index and column index to row index, and if I create another matrix, that will become a transpose matrix. Each and every element in this matrix, row and column index have to swap to get this kind of matrix. If you give 1, 2, 3, 4, 5, 6, transpose matrix will be 1, 2, 3, 1, 4, 2, 5, 3, 6. Like this, it will become. So we should get the same output if we have achieved that. Okay. To transpose the matrix, where I have to swap the the rows with columns and columns with rows. Okay. For that, row indexes with columns and column indexes with rows. Okay. So here I'll write transpose. I'll create a method transpose matrix like this. I'll create and have to pass the matrix here. That is AR only. I'll give the name AR here, the form of array. I'll get that. And here I'll write the body of this method. And I'll call this method, guys. Okay. So here I'll print a statement saying after transposing matrix. After transposing matrix, again I'll print the matrix, guys. After transposing matrix, again I'll print the matrix. I'll print that later. For now, in order to transpose this matrix, I have to call this method. And pass this matrix, original matrix, as an argument to this method. So whatever the logic that I'm going to write, that is very important. That's what is the answer for this question, guys. I write a Java program to get the transpose of the matrix. How to make this AR of ij will become AR of ji. Okay, that's what we have to do. Okay, so rows to columns and column indexes to rows. We have to give. For that to happen, first we have to get the number of rows. Okay, int rows is equal to AR dot length. This is rows. Int columns is equal to, take anything AR of 0, let's say, dot length. This is the number of columns. Now I have to create a resultant matrix, transpose matrix, otherwise integer array. Okay, transpose tmat. Tmat I'll say. Okay, tmat means T matrix. Tmat is equal to new int of, here in place of rows, you give these columns. And in place of columns, you give this rows. You give this rows. In place of columns, you give this rows. That's what you have to do. After that, what you have to do is you have to write like this. For int I is equal to 0, I less than rows, I plus plus. Okay. Just see what I'm trying to do. Okay. Just see what I'm trying to do. For int j is equal to 0, j less than columns, j plus plus. Okay. I will iterate through all the elements of this original matrix that is received as a argument or parameter to this parameter, whatever, while calling that particular method, whatever I got, I'm going through that. So here I'll simply write down. Okay, here I'll simply write down tmat of tmat of I j is equal to tmat of ij is equal to tmat of ij is equal to AR of ji, AR of ji. This is what I want to do. Let's see whether this logic will work or not. Even I don't know, but let's try it out and see whether that is working or not. Okay. Tmat of ij is equal to AR of ji, I'll say. Let's see what will happen. Here, number of rows, how many will come? If I pass that particular matrix having this particular matrix when I'm passing, how many rows are there? 2 rows. Row 1, row 2. And in that, how many columns are there in the row 1? 3 columns. So 3 will come here. So here I am creating column size as this rows as here rows should be there, but I provide columns here. That means it will become size. This is the size of this. Okay, 3 rows and 2 columns. 3 rows and 2 columns. Now here I wrote for int I is equal to 0, I less than. Here I'll write instead of rows, I'll write tmat dot length. That will be better. So what is the tmat dot length? Tmat dot length will become 3. Okay. Then only we can understand, right? So here j is equal to instead of columns, we have to write tmat dot tmat of 0 dot length. This will be columns. Okay. Resultant transpose matrix columns. 2 will be there. Okay. So now tmat of ij means here I is what? I is 0. 0 less than 3. 0 is less than 3. Okay. 0 is less than 3. That is true. I is 0, 0 less than 3. Here j is 0. 0 is again less than 2. Here 0 less than number of columns, okay, of this resultant T matrix. Then after that is also true, will come inside. Here tmat of ij means 0, 0. Tmat of 0, 0 is equal to aj of ji. Here j is 0, I is 0. Same thing. That means here what will come? Here what will come, guys? Here if 0, 0 is nothing but 1, right? After interchanging also it's 0, 0. So it will be the 1 only. The first element 1 will be stored. Then after that, the next thing, j plus plus will happen. J will become 1. 1 less than 2 will become true, will come inside this. And tmat of 0, 1. Tmat of 0, 1. That is, this is 0, 0. This is 0, 1. Okay, 0, 1 is this one. In that place, AR of ji. That means j is 1 and ji means what? J is 1 and I is 0. 1, 0. AR of 1, 0 is what? AR of 1 is this one. In that 0 is what? 4. 4 will come here. That's what is the thing. Okay, it's working, looks like. Okay, then I'll make j plus plus, j will become 2, 2 less than 2 is false, will come out of the inner for loop and we'll go to the external for loop where the value of I will become 1, 1 less than 3. 1 less than 3 is true, will come inside the for loop, inner for loop, again j will become 0. Again 0 less than 2, 0 less than 2 is true, will come inside that. Your tmat of ij means I is 1, j is 0. So 1, 0 means what? Here, at this location. Index 1 row and 0 is a column, this place. This is the first row and 2 columns completed. Second row, first column. In that place, we are assigning what? AR of ji. J is 0, I is 1. 0, 1 means 0 is this one, 1 is 0, 1, 2. 2 will come here. Okay, 2 will come here. Done. And after that, j plus plus j will become 1. 1 less than 2 is true. 1 less than 2 is true. Okay, 1 less than 2 is true. So we'll go inside that. And here, T mat of ij. Ij means I is 1, j is 1, 1, 1. T mat of I 1, 1. T mat of 1, 1 means this is 0. This is 0th row. This is 1 row. In that index 1, 0th column, first column, this place. That means this place. What will happen here? What we are assigning to that place, air of ji we are assigning. That is 1, 1 only. What is 1, 1 here? 1. In that 1 is 5. So 5 will be coming here. Now, j plus plus j will become 2. 2 less than 2 is false. Will come out of this inner for loop. And here, I plus plus I will become 2 finally. 2 less than 3 is again true. So will come inside here. J will become again 0. 0 less than 2 is true again. Will come inside that. T mat of ij. I is 2. J is 0. 2 0 means 2 means 0th row, 0th index row, first index row, third index row, second index row. So here 2 is coming here. 2. And in that j is 0 means the first column, this place. In the first place, what will come here? Air of ji will come. Air of ji will be assigned. What is air of ji? That is j is 0, I is 2, 0, 2. What is 0, 2 here? 0 is this one, 2 is 3. 3 will come here. Okay, after that, j will become 1, 1 less than 2, again true, will come inside the loop. Then T mat of ij, 2, 1. T mat of 2, 1 means 0, 1, 2, 2. In that 1 means 0, 1. This is a place, it will be assigned. In that ji means 1, 2. What is 1, 2 here? 1 is this one. In the 2 means 0, 1, 2, 6. 6 will come here. Then j will become 2. 2 less than 2 is false, will come out of this for loop. And I will become 3. 3 less than 3 is again false, will come out of the external for loop. So here, whatever the original format that is printed like this, 1, 2, 3, 4, 5, 6, the transpose of this particular matrix will be like this, 1, 4, 2, 5, 3, 6. This will be the resultant matrix. Okay. This is how we can make the matrix transpose by swapping the, you see here ij is swapped with ji. Okay. We are swapping the values of I and j indexes. Okay. Rows and columns we are swapping here. And because of that, we are getting the after transposing the matrix, we have to return this matrix, guys. This T mat we have to return from this method. Return T mat we have to write. And here, return type should be 2-dimensional array. That is nothing but, matrix, nothing but a 2-dimensional array. The return type will come as like this integer array. T mat 1. Okay, I'll just give some name like original mat1 got converted to transpose matrix. And here I would like to print the matrix, guys. I would like to print the matrix. After transposing, what is the output? How does this print matrix will look like? Okay, this T mat1 I have to pass. T mat1, which is a resultant transpose matrix, I'm going to pass, and that will get printed using this previous method. Now, if I run the code, right click, run as Java application. You see, 1, 2, 3, 4, 5, 6 got converted to 1, 2, 3, 1, 4, 2, 5, 3, 6. Okay, this is what is the resultant transpose matrix. So you may ask me, this will work only in this case. It may not work in another case. What I have to do like that? You may have a question or confusion here. So what we do is we'll take the input from the user itself. We'll create this. We'll get this matrix 1 from the user itself. How to get that from the user itself? So using the scanner, you can make this particular program a bit complex. Scanner is equal to scanner. Using this, we'll collect the input from the user. Okay. So whenever you are writing programs in the interviews, make sure that take the advantage of this scanner class wherever it is possible, so that the answer will look good, and the interviewer will understand that you have written the program in a better way. So system.out.println, I'll write down here enter number of rows. Okay, and I'll collect the number of rows for the original matrix. I'll just simply write down scanner dot next int. I'll collect the rows here. Int rows, I'll say. Int rows is equal to, or int r is equal to, otherwise r is also fine. Then after getting the number of rows, I would like to ask the user to enter number of columns in that matrix, in the 2-dimensional array. Enter number of columns, enter number of columns, colon. And here I'll write down int C is equal to scanner dot next int. Scanner dot next int. I'll write like this. Okay, int C, number of columns is equal to whatever the user enters, the number of columns that this array should contain. Now, here, instead of writing like this, I'll write after getting the number of columns, I'll create an array like this. A new int of rows and columns, whatever the user has given, that rows and columns. Now, what I want to do is I want to ask the user to enter all the array elements. All the array elements, okay? Into the two-dimensional array, all the array elements we have to enter. So how to enter that? For that, I'll write the for loop. For int I is equal to 0, I less than r, I plus plus, okay? And here I'll write down for int j is equal to 0, j less than c, j plus plus. I'll write like this. And here I will do something. I'll simply say mat of I j is equal to scanner dot next int. Okay. So here I'll write simply, instead of writing here, I'll write the print statement here so that you will enter array element system.out.println. Until the user enters all the array elements, it will keep asking system.out.println. Enter array matrix element, array matrix two-dimensional array element, okay? Element like this, I'll ask. So until this for loop is completely completed, the user has to keep on entering the numbers into this two-dimensional array, and original array will be created and it will be printed. After the transpose of the array will be created and it will be printed. So let's run this and see whether this scanner object, you can close it somewhere, guys. Maybe you can close it here. Scanner dot close. At the end of the program, you close a scanner dot close as a best practice. Now run the code here, right? The program has become now very good. Run the code, enter number of rows. Let's say the rows are 4, the columns are 5. I'm saying columns are 5. Enter array matrix element 1, then 2, then 3, then 4, then 5, then 6, then 7. I keep on entering. Then 8. Total 5 4s are 20 elements. It will ask, guys. Okay. Then 9, then 0, then again 6, then 3, then 2, then 4, then 8. Okay. Then 5, then 1, then 0. Still, how many elements I have to enter? Let's see. Then 2, then 7. You see, the original matrix is like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 6, 3, 2, 4, 8, 5, 1, 0, 2, 7. But here what happened? This 1, 2, 3, 4, 5 became like this: 1, 2, 3, 4, 5. Here 6, 7, 8, 9, 0 becomes 6, 7, 8, 9, 0 column. This row has become columns here. 6, 3, 2, 4, 8, 6, 3, 2, 4, 8, 5, 1, 0 to 7 has become 5, 1. So it's working for anything like this. This is a way you can make the program more dynamic. So guys, the program is very, I made the program very good, and I have tried my level best in explaining you how the program has to look like and all. So now what you guys can do is take a screenshot of this code. Guys, you can take a screenshot of this code. Okay. And for practicing in your machine, you take the screenshot of this code. Okay. So I'm waiting here. Once you've taken the screenshot of this main method, now, assuming that you have taken the screenshot, I'll go to the second method, take the screenshot of this method, transpose matrix method, hoping that you have taken the screenshot of this transpose matrix. Now I'm going to the third method, print matrix method. You can take the screenshot of this print matrix method. By writing the code in this way, the code will be easy and very comfortable. We can write the code and logic is separated. This actual logic is, hoping that you have taken the screenshot for this. This actual logic you have to understand. If you have this knowledge of this logic, remaining all things are very easy, guys. Just are the common thing. But this transpose matrix method has the actual logic or actual answer for this particular Java program. So hope guys you got the answer for this question in a detailed and practical way in this session. So that's all for this session. Thank you. Bye-bye.